Hello everybody, in this video we are going to continue our conversation about how to factor a basic quadratic function, or in this case an expression. So with that being said, I do want to remind you that some of the previous videos we talked about and reviewed how to find the GCF, how to factor by grouping, but mostly we spent a little bit of time talking about how to expand something that has 3 terms. So if they give you an expression with 3 terms, our first step is to find 2 numbers that will expand this into 4 terms. Because if we can have 4 terms, then we can use what we know about factoring by grouping to finish this problem off. So in the previous videos when we were just expanding, we weren't finishing the job. We were just saying, okay, what do we need to do to go from 3 to 4? Once you get to 4, you factor by grouping, which is something we've been talking about for a while. So in this video, I'm going to show it how to do it from beginning all the way to the end. So let's go ahead and look at this example right here. Okay, so I have some steps right here written for you. We're going to expand this expression from 3 terms to 4. Then we're going to factor by grouping, and then don't forget to check for your GCFs at the end to make sure you can't simplify it any further. So let's jump into it. So first thing I'm going to do is put an understood 1 here, and I'm going to label this A, B, and C. Okay, so remember your A has to have the x squared, your B has to have the x, and your C is the constant. So according to what we did here, we need to start with A and C. So we know A is 1, C is 18. So we're going to multiply A and C. So 1 times 18. Now I know that 18 is negative. I'm actually not worried about the negative right now because this negative tells me I'm looking for numbers that subtract to give me 17. Oh, my pen's going out. Okay, so we'll come back to the negative in a minute. But right now we're multiplying 1 and 18 and we get 18. That means I need to use the 18 to find all the numbers that multiply to be 18. So all the different factors. So I'm going to use a space over here to write 1 and 18. I like to start with 1 and then go 1 number at a time. 2 will divide into 18 9 times. 3 will divide into 18 6 times. 4 will not. 5 will not. 6 already on this list. So because I kind of came full circle here, these are the only numbers that when you multiply them give you 18. All right, take the number in the middle, which is this negative 7. This negative 7x, we're going to write it at the bottom right here. And I'm going to remind you what we're looking for. We're looking for 2 numbers that when you multiply them give you 18. We listed them right here. But we also need those 2 numbers that when you subtract them to give you 7. I know that's a negative 7, but right now I'm not worried about the negative. I just want to find 2 numbers that subtract to give us 7. So 18 minus 1 is 17. 9 minus 2 is 7. So I'm going to use these numbers right here. That's what I want to use. Because if I multiply 2 and 9, it does give me 18. And then 9 minus 2 does give me 7. So I'm going to put 2x, 9x. Now here's the thing. If you remember from the previous video, if you're subtracting, one of these numbers needs to be a positive and the other one needs to be a negative. So I need to make sure to place those positive and negative correctly so that way I get not just a 7, but a negative 7. So my trick is, if you need a positive and a negative, you're going to give the negative on this 7 to the bigger number. So 9 is bigger than 2, so I'm going to make this a negative, which makes this a positive. Now, if that doesn't seem right, you can use your calculator to check it. So if I go here and I say 2 minus 9, it does give me a negative 7. Say, for example, you switch them and you do 9 minus 2. Notice it gives us a 7, but we don't need a positive 7. We need a negative 7. So the only way that's going to work is if the 9 is negative, the 2 is positive. All right, so we're going to expand. And we're going to say positive 2x, negative 9x. So we're replacing that middle term, that b value, with two numbers. Take the first number, bring it down, 1x squared. Then bring down the negative 18. Since now we have 4 terms, we're going to split it. Remember, the negative belongs to the 9. And we're going to find our GCDs, our GCFs, and we're going to simplify it all the way. So let's do that for this one. The GCD on 1 and 2 is 1. They both have x's, so I'm going to take 1x out. And then we're going to divide and subtract. 1 divided by 1 is still 1. 2 minus 1 is 1. All right, let's do that again. 2 divided by 1 is 2. 1 minus 1 is 0. I'm going to take that negative in the front, bring it down. If I find the GCD for 9 and 18, I know some of y'all want to say 3. 3 does divide into both of those, but that's not the biggest number. So the biggest number is 9. So 9 will divide into 9, and 9 will divide into 18. Keep in mind, they both don't have x's, so we're just dividing by 9. But not just 9, a negative 9. So negative 9 divided by negative 9 is 1. Bring down the x. Negative 18 divided by negative 9, positive 2. And then remember, when you're factoring by grouping, both of these have to be the same. So I'm going to write it down, x plus 2. Remember, this is understood 1, so you can put it there or you can leave it off. 1 can come and go as it pleases. All right, so with that, I'm going to cross that out. The only thing that's left over is this 1x and this minus 9. So I'm just going to say x minus 9. Nothing will divide out of here. Nothing will divide out of here. So that is my final answer. Like that. All right, let's take a moment to do the same thing, but with the second problem. All right, I'm going to walk through this one a little bit faster. So this is A, this is B, this is C. I'm going to multiply A and C. So we're going to say AC is 5 times 72. Because remember, I'm using the negative as a minus, and we're trying to figure out what numbers we'll subtract to be 31. So I don't know what 5 times 72 is, so I'm going to go ahead and type that in there. 5 times 72 gives us 360. 360 is a pretty big number. So we need to find all the numbers that multiply to be 360, so we can then find numbers that subtract to be a positive 31 in. All right, I'm actually going to pause this and list my values. So I'm going to set it up first, but just to save a little bit of time, I'm going to pause the video and list my values. All right, so what I've done is listed all my factors, and you can tell that I probably didn't list all of them, but I do want to point out, if you know what you're looking for when you're doing your list, you can stop once you find it. So remember what I told you, we're looking for numbers that subtract to be 31. So as I was writing these down, I was like, okay, if I subtract them, what number will it be? And I kept on going until I found 31. So if you look right here, I actually went a little bit past. If you take 9 from 40, it will give you 31. So it kind of helps when we're actually know what we're looking for when we create that list. So that tells us whether we need to keep on going to find what number we're looking for, or we can stop. All right, so for this one, remember this is a positive 31. So because I'm subtracting, one needs to be a positive, one needs to be a negative. So let me write it out first, and let me do 9n and then 40n. Because I'm looking for a positive 31, I'm going to give this plus sign to the 40 because 40 is bigger than 9. So I always give it to the bigger number. So if I take a positive 40 and subtract 9, it will give me a positive 31. So let's expand. And actually, I'm going to take this and I'm going to kind of write it down here to kind of, because I feel like I have to squish it. So I'm going to replace the 30n with these two numbers. So I'm actually going to write it out and say 5n squared, because that stays the same. I'm going to put 9n plus 40n minus 72. So I just want you to know that I replace this number with these two, like this. Okay. And then from here, I no longer have 3 terms, I have 4 terms. So I'm able to factor by grouping. So I'm going to go ahead and work this one out. The GCD between 5 and 9 is 1. And I'm going to take out 1n. So let's divide and subtract. 5n minus 9. Okay, bring down the plus sign. Now, if I take the GCD of 40 and 72, so give me a second, 40, comma, 72, it tells me that 8. Now, they don't both have an n, so we're just dividing by 8. 40 divided by 8 is 5. Negative 72 divided by 8 is a negative 9. And this is your checkpoint. Both parentheses are exactly the same. So we've done something right here. So let's write it down, cross it out. And you can see that what's left over is 1 and 8. Actually, 1n and 8. And so if I find the GCD of 5 and 9, I'm going to get 1, so it can't be factored further. If I do the GCD of 1 and 8, once again, 1, so it cannot be factored any further. So this is my final answer. And so, like I said earlier, this is a process. And to be honest, this is probably the hardest thing we're going to do in Algebra 1, but it's so important because Algebra 2 expects you to know this, and it comes up so many times that we need to build that foundation now. So with that being said, just remember that we can take something that has 3 terms, turn it into 4 terms. We can factor by grouping to factor it completely. Okay, so I hope that these examples that we've done together have helped you understand this a little bit better. But I'll see you guys in the next videos.